useful in relating some physical properties of solutions, say vapor pressure, and quite useful in describing calculations involving gas mixtures. Then at 35.5 degree volume by volume solution of ethylene glycol and antifreeze is used in car for cooling engine. We all know, पुरानी movies में जाते हैं ना, ले आने वहीं पे आ जाते हैं सब, मैं मान लो. It lowers the freezing point of water from 0 degree.
Hello and welcome back to my channel Pandey Classes. So far we have discussed about introduction of solutions और solutions के introduction के बाद हमने पढ़ा है concentration terms. Concentration terms में हमने समझा that how and why these concentration terms are important for us for chemists. So children, whenever we want to prepare same kind of solution with uniformity, so we need to use concentration term. So concentration term makes us to prepare solution in an easier way of the same strength. Okay, so there are concentration terms that we have discussed is first mole, like first is mass percentage, volume percentage, then grams per liter, then after that we discussed about molality, normality, formality, parts per million. So out of these, if I talk about board exams, so for board examination point of view, mass percentage, volume percentage, molarity and mole fraction, these four are very important. So I hope you have gone through the topic. So let us start with the new topic of the same chapter, and the topic is solubility. That what is this solubility? So let's start with solubility. So we all know, we all have some prior information about the solubility. That solubility is defined as what? It is defined as the amount of solute that can be dissolved in a definite amount of solvent. So here we take 100 gram as a definite or specific amount of solvent. So solubility is also again very important, okay, because it is telling us that what concentration maximum can be dissolved in any solvent at a given temperature. Remember, whenever we talk about solubility, solubility is always discussed at a specific temperature only. Always remember this. Then what are the factors which influence solubility? So if we talk about the factors, so nature of solute. So nature of solute decides the like solubility. Like if we take sugar, अगर हम चीनी को पानी में डालते हैं और नमक को पानी में डालते हैं, so which one will get dissolved immediately and which one will take some time? So it depends on what? It depends on totally nature. So ionic compounds are more soluble. Nature of solvent also. Temperature, because temperature decides, because temperature changes the intermolecular distance. Then we have pressure. After this we have, okay, so after this let us take one case here, and the case that we are taking here is salt in water. So salt, we know, table salt is ionic in nature, ionic compound. And if we talk about water, so water is a polar solvent. Polar, I hope we all know, we all remember that what are polar means having poles. So nature of solute, if it is ionic, so it is having very good solubility. If we have solvent as a polar solvent, so again here also what will happen? Solubility will increase. Temperature, again it will increase the solubility. And it depends on condition, that there are some conditions where temperature is increased. If temperature is increased, then there is decrease in solubility. And then we have pressure. If we talk about pressure, so pressure also, this factor is limited. It's not applicable to all, right? So let us discuss the effect of these factors on solutions of a solid and a liquid. So one we have taken here, polar solute dissolved in polar solvent, non-polar solute dissolves in non-polar solvent. Always remember, like dissolves like. Okay. So if we have polar compounds, so it will dissolve in polar. If we have non-polar, so it will dissolve in non-polar compounds. Then effect of temperature we have already discussed. Enthalpy change decides that's what I mentioned, that there are some factors which decides the solubility. So enthalpy change in solution is denoted by delta H, and we know that if this enthalpy change is negative, so it's exothermic, and if this enthalpy change is positive, so it is endothermic. So in case of endothermic reactions, like here we have here we have delta. Suppose here we have delta X. So it's exothermic condition. So in exothermic condition, heat is evolved. And if in such situation we are increasing heat, so solubility will somewhere decrease. Okay. So here in this case, solubility is going to increase with what? It will increase with it will decrease with increase in temperature. Okay. Just a second. This thing I missed. So here we were just discussing about endothermic reactions. So endothermic reactions with delta H is positive. So with increase in temperature, solubility is increased. And if we talk about exothermic reactions, so in exothermic reactions, this delta H is smaller than 0. So here in this case, solubility decreases with increase in temperature. Generally, the solubility of solute in water solvent increases with increasing temperature. So this is the general observation, not a rule. So sodium chloride solubility is not much affected by increase of temperature. So these are solubility graph with respect to temperature. So here as you can see, we are having three solvents: sodium chloride, potassium chloride, sodium bromide. Okay. So on x-axis we have plotted temperature in degrees Celsius, solubility in grams. So this is the plot that we are having. So as you can see, let us observe for potassium chloride. So as you can see, with increase in temperature, there is increase in amount of potassium chloride dissolved, whereas in case of sodium chloride and sodium bromide, this change in solubility, amount of solute that is getting dissolved, is not very much affected. So somehow it also depends on what? It also depends on the nature of solute. Then this one we are having three different cases: potassium bromide, sodium nitrate, and potassium nitrate. So here, if the temperature is increased, there is drastic change in the solubility. Okay, solubility of a solid in a liquid. Effect of pressure. So if we talk about pressure, so pressure does not play any significant role here. Why pressure does not play any significant role? Because liquid as well as solid both are incompressible in nature. So whatever amount of pressure is applied, it hardly matters. It hardly decides the solubility in case when solid solute is dissolved in liquid solvent. Type of solution based on solubility. This is something important that we are going to discuss. So solutions. So solutions we all know: saturated solutions. Then we know unsaturated solutions. Then we have one more term. That term we call it as super saturated. Okay. So saturated solutions. So what are saturated solutions? So saturated solutions are those which in if like these are solution if in which if further small amount of solute is added, so instead of getting dissolved, it will convert into precipitate. So such solutions we call it as saturated solutions. Okay. No more amount of solute can be dissolved at the same temperature and pressure is known as saturated solution. There exists an equilibrium between dissolved solute molecules and undissolved solute molecules. So this is very important. There exists an equilibrium condition between dissolved and undissolved solute molecules. Solute plus solvent gives solution. So solvent hold as much solute as it is possible at that temperature. Undissolved solid remains in flask in form of precipitate, and this dissolved solute is in dynamic equilibrium. Dynamic equilibrium means which keep on shifting. Okay. So dynamic equilibrium is what? When a solid solute is added to a solvent, some solute dissolves, which are called dissolution, and some are what? Some particles collide with other solute particles and get separated out of the solution, which is called as crystallization. So dynamic equilibrium, at a dynamic equilibrium condition, this dissolution and crystallization process both will take place simultaneously. So this is we have added, and others are dissolved or dissolution we call it as, and the remaining part we call it as crystallization, which will further settle down. When the process of dissolution and crystallization started to occur at the same under under the same conditions, so such we call it as dynamic equilibrium. Unsaturated solutions. So unsaturated solutions are those solutions in which if further small amount of solutes are added, so it gets dissolved. So such we call it as unsaturated solution. Okay. So the amount present in is less than the saturated solutions. And if we talk about super saturated solutions, so super saturated solutions are those which contains more amount of solute than present in saturated solution at the same temperature and pressure, and it is containing more amount than saturated one. That's why we are calling it as super saturated. And solvent holds more solute than is normally possible at that temperature. Suppose this is one solvent, we are adding solute into it, and then it holds maximum amount of solute as compared to the saturated one, then only we call it as super saturated. Solubility of a gas in a liquid. This here the conditions are just different from the condition that we have discussed in case of solid in a liquid. So is the very common example for this is soft drinks. So we know that soft drink bottles are filled with gas, and what is that gas? The gas is carbon dioxide. That's why these soft drinks are also called as carbonated drinks. So when we have solubility of a gas in liquid, so here what we have, so this is the condition. Do you know that most important gas that dissolves to a small extent of 5 to 6 ppm in water and saves the whole flora and fauna under sea? Yes, which important gas it is? This important gas is oxygen only. Hydrogen chloride gas, ammonia gas, sulfur dioxide gas, etc. are highly soluble in water. Easily liquefiable gases are more soluble. Solubility of gas is greatly affected by pressure and temperature. Okay. Effect of pressure. So what happens in case of gas in liquid? What happens here? Like gases are having larger interparticle spaces. Okay, it is having larger interparticle spaces. So once the pressure is applied, so what happens? This interparticle space is decreased. And also we can say that the gases are compressible in nature. So once the pressure is increased, its solubility or its interaction with the solvent interface, that is liquid in state, that increases. जिसकी वजह से क्या होगा? जिसकी वजह से यहाँ पर होगा solubility में increase. the increase of weight on the piston, solubility of gas increases. Assume this system to be in a state of dynamic equilibrium. Okay. Under the conditions such as P and T, rate of gas molecule entering and leaving the solution phase is the same. So we call it as what we call it as dynamic condition or equilibrium. And here W is used as a weight that exerts pressure on gases. Concentration of gas molecules per unit volume increases and interaction between the solvent molecules and the gas molecule increases, resulting in more solubility of the gas. Observation from the above figures. Assume this to be in a state of dissolution and crystallization equilibrium. Now increase the pressure over the solution phase by compressing the gas to a smaller volume. And what will happen in that case? As a result, increases the number of gas molecules per unit volume over the solution. This increase in the pressure of a gas above solution will increase the solubility and it will attain the new equilibrium condition. Now, what is the effect of temperature? You know why we store cold drinks at lower temperature or under a refrigerator only? Because if the temperature is increased, kinetic energy of the gases will increase. And if kinetic energy will increase, so its random motion will increase. And if its random motion increases, so there will be less interaction between solute and solvent particles. So somehow it is going to decrease the solubility. So I have a general, just a very easy and very general question. If we talk about aquatic life, okay, if we talk about aquatic life, so aquatic life is like aquatic species are more comfortable during winters rather than summers. So what's the reason? So here the reason lies somewhere in this solubility term only, because if the temperature is less, so gases are more soluble, and if the gases are more soluble, so in that case what happens? In that case, more amount of dissolved oxygen is available, and if more amount of dissolved oxygen is available for aquatic species, so in that case their life becomes comfortable. That's why for aquatic species, their life or survival is more comfortable during winter season rather than summer season. So this is one graph that we have plotted here. So solubility in and temperature. So here we have helium, carbon monoxide, oxygen and methane. So as you can see, helium is very less soluble and methane is highly soluble. Important note: when a gas is dissolved in liquid, heat is evolved during this process, and if heat is produced, so the process is exothermic. So exothermic, huh. So dissolution process follows dynamic equilibrium, Lee Chatter's principle. In exothermic process, the solubility should decrease with increase in temperature. So these are the topics that we have already discussed. Okay. After this, we have Henry's law, and this Henry's law is this law is going to discuss about the solubility only, that how the solubility is affected. Okay. So let us talk about Henry's law. So can you tell me who is the first person to give quantitative relationship between solubility of a gas in a solvent and pressure? So person was Mr. Henry only. And here we are going to discuss about Henry's law. So the law states that at a constant temperature, the solubility of a gas in a liquid or solution is directly proportional to the partial pressure of the gas present above the surface of the liquid. So somehow this Henry's law is stating that the amount of the solubility of gas it depends on the partial pressure of the gas also. So if we change it into mathematical form, so how it can be written? I hope we all know about partial pressure. So partial pressure is like pressure exerted by the solute particle or the gases. Okay. So Henry's law, the partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas in the solution. So here we'll give equation to this definition. So Henry's law is expressed as P is directly proportional to the mole fraction, that is denoted by chi. So when proportionality sign is removed, so here we have Kh. So this Kh is Henry's constant, and this Henry's constant is very disputed. Like if we go through the Henry's constants, we will find out that exactly this Kh is not a constant. So Henry's law constant Kh. Can you draw a graph between partial pressure and mole fraction of gas in a solution from the above statement and predict the nature of the graph? Yes. So this is x-axis, y-axis, and partial pressure of HCl in torr. Torr is the unit of pressure, and mole fraction of HCl in cyclohexane. So this is one graph for hydrochloric acid, how it gets, like we have studied here. This was studied by Henry, okay, not Henry Moseley. Here it was studied by Henry, and he studied that what pressure exerted by HCl when it is dissolved in cyclohexane solvent. This graph will be straight line passing through the origin. Helium, hydrogen, nitrogen, oxygen, argon, carbon dioxide, formaldehyde, methane, vinyl chloride, etc. Why? Why we cannot, like, we cannot find out, or we cannot guess? Here is the answer for you. Because what I said, it's dependent upon what? It's dependent upon nature of the gas. This Kh value exactly depends on the nature of the gas and the temperature. अब अगर ये जो Kh है यानी कि Henry's constant, if it is depending upon nature of gas, अगर ये nature of gas पे depend कर रहा है, temperature पे depend कर रहा है, तो काहे का constant है, right? So in soft drinks and soda water, carbon dioxide is passed under high pressure and sealed. Why? Because increases the solubility of carbon dioxide, and this carbon dioxide act as a cooling agent. Okay. Scuba divers have a high concentration of dissolved atmospheric gases in blood. Why? So the answer is scuba divers go deep into sea, which results in high pressure underwater, which causes more solubility of gases inhaled based on Henry's law. So this thing should be very clear. Scuba divers, we know, जो समुद्र के अंदर जाते हैं, oceans के अंदर जाते हैं, like they carry cylinder, that they carry oxygen cylinder. We used to call it as oxygen cylinder, but that gas does not completely contain oxygen. Basically, it's a air only, which contains oxygen. Okay, so when we go deep inside the ocean, suppose this is the ocean, and when we are going deep inside the ocean, so what will happen? Water will start exerting pressure on us, and these gases will what? Like nitrogen like gases, it will start dissolving into our blood. Okay, and if it is getting dissolved, and once that scuba diver comes out of the water, so pressure will change, and that nitrogen gas will create or produce bent like small bubbles will be there in their blood vessel, which will which will be responsible for very good amount of pain. So in order to eliminate this, small amount of inert gases are also added because inert gases की जो solubility है, that solubility is very less. So whenever scuba diver comes out of the water, he does not suffer any bend or pain. Okay. When scuba divers come out to the surface, experiences a medical condition known as bends, which are painful and dangerous to life. Why? We have already discussed this. Okay, formation of bubbles of nitrogen in the blood. What is the scuba diver air tank? So composition. So I told you it's very small amount of inert gases are added, helium only, and as you can see, nitrogen and oxygen. But we have one presumption that if a scuba diver is going into ocean or sea, so the cylinder that he is carrying must be having only oxygen. No, it's not only oxygen. It's basically air. Why do people living at hilltop or at higher altitude experience condition known as anoxia? We know that at higher altitudes the partial pressure of oxygen is less than that on the ground. This leads to the less availability of oxygen and less availability of oxygen in our blood. That's why if the percentage of oxygen is decreasing, so person leads to a condition of anoxia, kind of unconscious state. Between ammonium chloride and sodium chloride, which is more soluble with rise in temperature? Very good question. So, do you remember one graph we have discussed? Huh, that only. So, according to that, sodium chloride is less soluble, and here ammonium chloride is very, very soluble. Henry's law applicable at constant what temperature, pressure, volume, temperature and pressure. So it is applicable at constant temperature only. If N2 gas is bubbled through water at 293 Kelvin, how many millimoles of nitrogen gas would dissolve in 1.0 liter of water? Assume that nitrogen exerts a partial pressure of 0.987 bar. Given that Henry's law constant for nitrogen at 293 Kelvin is 76.48 kilobars. So just go through the question. So first is temperature is given, that is 293 Kelvin. What it is asking is, it is asking for how many millimoles of nitrogen gas would dissolve in 1 liter of water. And here one constant is also given. Not constant, it's a partial pressure of nitrogen, and the formula we all remember. What's the formula? Solubility equals to Kh into partial pressure. So P equals to Kh into partial pressure or mole fraction. Okay. So solubility of a gas is related to mole fraction in aqueous solution. So P equals to Kh into chi, and P is what? P 0.987. It's already given from the data, and Kh is also given. So simply what we'll do, x equals to P upon Kh. So if we divide, we'll get what we'll be getting, N1 upon N1 plus N2 moles of water, N2, and this way we'll be getting 55.5. So 1.0 liter of water equals to 1000 gram, since density of water is 1 gram per ml. So this chi gives us what? This gives us mole fraction. And if we talk about mole fraction, so it's a ratio of number of moles of solute upon sum of number of moles of solute and solvent. So here also we did the same thing. Here we did the same thing. N1 upon N1 plus N1 upon N1 plus N2. And then number of moles if we want to calculate. So how we can calculate? Just remember this, moles of water in N2. If we have 1 liter of water, so always remember 1 liter of water, 1 liter of water equals to 55.5 moles. Always remember this is, consider this as a standard result. Okay. So since N1 is much smaller than N2, so chi equals to N1 upon N2, then N1 equals to chi into N2. So 1.29 into 10 raised to the power minus 5 into 55.5, and this will give us the answer. 7.16 into 10 raised to the power minus 4 moles, and 1 mole equals to how much? 1000 millimoles. So 7.16 into 10 raised to the power minus 4 into 1000. So this will be equal to 7.16 into 10 raised to the power minus 1, or 0.716 millimole, or m mole. Solvent property is solvent property is dielectric constant, breaking strength of solvent on interaction with solute molecules. So you must have studied about dielectric constant. That this dielectric constant is, it decides the strength. Like it's like dielectric constant. We talk about solvent part only. Suppose if we talk about water, so water dielectric constant is 80. So once we add any ionic compound into it, its dielectric constant is very high, and it immediately breaks the ion, break the positive and negative ions into cation and anion, and the ions become more mobile. Like it becomes mobile. Once we apply electric field, it starts running. Okay. So the energy term here, lattice energy and hydration energy. So what is this lattice energy? So if we talk about lattice energy, so it is the amount of energy required, okay, for what? It is the amount of energy required when 1 mole of crystal is broken into constituent cation and anion. अब हम NaCl को वाटर में ऐड करेंगे, तो NaCl क्या है? आयनिक कंपाउंड है, तो Na प्लस और Cl माइनस दोनों पॉजिटिव और नेगेटिवली चार्ज है, तो दोनों के बॉन्ड्स, दोनों के बीच में क्या है? आयनिक बॉन्ड है, एंड दैट बॉन्ड इज वेरी स्ट्रॉन्ग. So the energy required to break the bond, we call it as lattice energy. So this lattice energy term is endothermic in nature. Hydration energy. So if we talk about hydration energy, so this is the amount of energy released, okay, when 1 mole of particles are surrounded by solvent molecule. We call it as hydration, and this we call it as exothermic in nature. Okay, so if lattice energy is higher than hydration energy, remember lattice energy and hydration energy. If lattice energy is higher than hydration energy, the solubility will be less. If lattice energy is lower than hydration energy, solubility will be very